Good morning, students. Today we start a new chapter, which one is chapter number 10, circles. So already in class 9 we discussed about the definition of circle. So we repeat this one again here. A circle is a collection of all points in a plane which are at a constant distance from a fixed point. So as you see here, the diagram is given. So you see this one is a circle. So the fixed point here already mentioned, you see the fixed point is this one, and from this fixed point, if we consider a constant distance, this one is the constant distance here we consider. In each and every place, if you consider the constant distance, so here after getting all these points, if you join, then this one we get a circle. So this one is the definition of circle. So that's why a circle is a collection of all points in a plane which are at a constant distance, that means radius, and from a fixed point which is known as center. So this one is the definition of circle, already we get in class 9. So now here, first thing we have to know here, if a circle given to you and a line, here line is mentioned as a PQ, line given to you. So what type of conditions we get if a line and a circle given to us? So now let's see here the first condition. So as you see here the diagram, the circle is this one. With respect to this circle, if a line we draw outside this circle, suppose the line is PQ here. So here the circle is this one, center is this. So the condition we get here, if the line, that means PQ, is called, in this case, what is the name of this line? This PQ is called a non-intersecting line. That means this line not intersecting this circle. Is it clear? So from the diagram it is very clear that this line not intersecting this circle. So next we move to the second one. So second one you see here, again we consider a circle which center this one, and the line is PQ, this line. So when we draw the line here, this line now intersect the circle at two places, as in the figure given you see here. So this point is we mention as A and another one is B here. So now the definition we get like in this way, if the line intersect at two places, then this PQ line is called secant, S-E-C-A-N-T, secant of this circle when the line intersect at two places, remember. So now finally the last one is here. If you see here, one circle is we consider, and in this case the circle, with respect to this circle, the line touching the circle at one place, which one is A, here we mention. If the straight line PQ only touching the circle, then in this case this PQ is known as tangent. Is it clear? Tangent to this circle. So for each and every point, that's why here one note is written, each and every point there is one and only one tangent at a point of the circle. For one point we get only one tangent. So here three conditions are we get. If the line outside the circle, then the line is known as non-intersecting line. If the line intersect the circle, then it is known as secant. And if the line touching the circle, then it is known as tangent. And for each and every point on a circle, we get one and only one tangent. Is it clear? This one is about tangent. Okay. Now let's see this note. Suppose we consider a circle and here we draw a line. This line touching the circle at the point P. So now when a straight line touching the circle at one place, remember touching the circle, then this touching point is known as point of contact. Is it clear? it is known as point of contact. So that's why here the definition is already mentioned here. What is point of contact? You see here. So what we say here, a circle we have to consider, and one point is we mention P, and if a straight line touching this P point, then this P point is known as point of contact. Is it clear? This one is the definition of point of contact. Now with respect to this, one theorem is here. So the theorem statement not mentioned here, already in book written this one. So you see from this book the theorem 10.1. So now in this case what happened, you see a circle we have to consider with center this one, and here one point we consider at this place, and from this point one straight line passing through this point, that means touching this point. So obviously this point already we know it is known as point of contact. Is it clear? And now here this point is what? Center. And now what you have to do, from the center we have to join the point of contact. If we join from the center to the point of contact, now you see here this line is what? Radius. So this radius is always perpendicular to the tangent. Is it clear? That's why if perpendicular it is what? Then it is 90 degree. Is it clear? So the perpendicular line, the radius always perpendicular to the tangent. So how can we get this radius? From the center if we join up to point of contact. Sometimes this radius, this perpendicular line is also known as normal. Later on we get this one. In higher studies you get this line we mention as a normal. Is it clear? This one is the theorem here. So that means the statement is what? If a tangent we drawn, if we join from the center to the point of contact, then this line is always perpendicular to the tangent. Is it clear? Okay. Now here, with respect to this, one question is we taken here. You see the question. So the question is like this: how many tangents can a circle have? So here in this diagram you see, in a circle there are lots of points are there. So we mentioned few points here. So lots of points are here. So from each and every point we can draw individually one tangent, isn't it? So the question is asking here, how many tangents can a circle have? That means the answer is what? Infinitely many tangents we can draw, because in a circle there are lots of points are there, many points are there. So that's why for each and every point we can draw one tangent. So that's why we can easily draw here infinitely many tangents. So next your task is what? The exercise 10.1, very easy exercise here. Some fill in the blanks are there. So you have to complete this one in your homework copy. So this one is your homework given to you. Exercise 10.1. Is it clear? Okay. Next topic is what? The number of tangents from a point on a circle. So here lots of cases we get, mainly 3 cases. Suppose we consider a circle. Now the first case you see, a point either lie inside the circle or on the circle or outside the circle. A point. With respect to a circle, a point lie inside the circle, on the circle or outside the circle. Mainly 3 cases we get. So the first case we consider, if a point lie inside the circle. So if a point lie inside the circle, we can't draw a tangent. So that's why here the line is written, if a point lying inside the circle, then there is no tangent, because how can we draw the tangent? Isn't it? So next, first one, this one. So second one is here, case 2. If a point lie on the circle. So obviously if a point lie on the circle, easily we can draw a tangent. So that's why here written, if a point lying on the circle, then there exactly how many tangent we can draw? One and only one tangent. For 1 point, one tangent we can draw. Is it clear? This one is the second case. Now finally the third one, and the third one is the most important one. If a point, now in this case, if a point lie outside the circle. So if a point lie outside the circle, that means this point you see. So obviously from this point we can draw two tangents. One tangent is this one and another tangent is this one. So now here at this place, suppose this one is the center. So if this one is the center and now here this tangent touching at this place, that means this point is point of contact, as well as this point is what? Point of contact. So external point is this one. So if you join these two, then we get a straight line, then it is known as tangent. Similarly from this point, if we join the point of contact, then this one is another tangent. So if anyone asks you how many tangents we can draw from the outside of the circle, if a point we taken outside the circle, then we have to say exactly two tangents we can draw. Now the main point is here what? From this external point up to the point of contact, this length is known as length of the tangent. I repeat this, from the external point to the point of contact, this length is known as length of the tangent. Similarly from this point to another point of contact is there, this one is also length of tangent. And most important thing is what? This length of tangents are always equal. Is it clear? From the external point, if you draw two tangents, then the length of tangents are always equal. Is it clear? So this one actually we get in theorem 10.2. The theorem 10.2 main statement is this one. If we draw two tangents from the external point, here the external point is we mentioned P, and the point of contact we mentioned A and B. So obviously PB, PA, these two are the length of the tangent, and these two length of tangents are always equal. So that's why we write here PA equals to PB. Is it clear? This one is theorem 10.2. So your main task is whatever we discuss here. So each and every topic you have to copy on your classwork copy, and as well as in homework copy you have to complete the exercise 10.1, and one more time you have to read properly and see the cases here. And in our next class we discuss the questions, mainly the exercise 10.2. Is it clear? Okay, thank you.